Hello, everybody. Hoping everybody's staying safe and calm out there, and everyone's healthy. So this is just the second part of a series of review videos for the unit that we were doing prior to the break here, whatever you want to call this. So the whole entire unit that we looked at was either solving for systems of equations or solving for equalities. And so the first video I did was solving for inequalities. If you haven't looked at that, go check that out. Second review video here is solving for systems of equations. And so solving for systems of equations means we are trying to find a point or points of intersection. So point or point of intersection. Now we're trying to find the full coordinates of where two functions may intersect. And we looked at different types. We looked at linear quadratic functions and we looked at quadratic functions. So linear quadratic functions could intersect in three different ways. So linear quadratic functions could intersect, let's say, twice. They could intersect once or intersect not at all. And then we have quadratic functions. So quadratic functions could intersect once, twice, not at all, or an infinite amount of times. And we are looking to find out if they intersect, where do they intersect? And so we have a variety of strategies that we can utilize to determine the point of intersection. So two different ways. We could have graphically, and we could have algebraically. And graphically is just as it seems, right? I can use my graphing calculator, put it into y equals some equation, and then find the intersection on my calculator. Algebraically means I can use one of two strategies. I can use substitution, or I could use elimination. Either of those strategies to help me find the point of intersection. I can always, solve with one of these and then verify graphically or verify with another algebraic expression. I can also verify by substituting that point in, right? Substitute the point in. If the left side equals the right side for both of those equations, that point is on the line, and therefore the point is an intersection. So let's go take a look at some questions. So solve the following system graphically. My favorite. Nice and easy. Put on the calculator. This question's even easier because they already give me the exact two functions. And they're just saying, like, where do they intersect? So I would just type them in on my graphing calculator. So x squared plus 12x minus 15. So I'll go here to y equals. Oh, it doesn't like that. So I'll go here, y equals x squared, I can't remember what I said now, x squared plus 12x minus 15, x squared plus 12x minus 15. And my second equation is 2x squared plus 19x minus 9. So 2x squared plus 19x minus 9. And so then I'll hit my graph button. And I can sort of see the functions there. I'm not totally sure. So I'm going to have to move. I could either just change my window, but I'm going to zoom out here. And I want my center on my screen to be maybe somewhere around here. So I'll just hit enter and it zooms out and hopefully I can see that. I'm gonna zoom out one more time just so maybe I can see if they intersect down here. All right, so it looks like they're gonna intersect twice. And so I can second trace my intersect. So first curve, enter, second curve, enter, guess, enter. So there's one intersect at -6, -51. So I'm gonna write that down. So -6, -51 is 1. And I have another intersect. Let's go check. Second trace. So remember, second calculate the intersect, hit enter on that. First curve, enter. Second curve, enter. And my guess is I think it kind of intersects a little bit. Where's my cursor? Higher up over here. So I'm just going to hit enter. And there's another intersect at -1, -26. And -1, -26. I could go check here and just go to change my window. Like it looks like I don't really need that wide of a window. So I could go like -50 to 50 maybe. And things might look a little bit nicer for me. A little bit nicer, yeah. And I could adjust it as I need it. So graphically, hopefully everybody remembers how to do that on their graphing calculator. Nice and easy. Also a way for me to verify. You know, if they say solve algebraically or if it's a multiple choice question, I always have my graphing calculator and I can go find where points intersect. So that's graphically. Let's go review how to solve using substitution. Now, I think that both examples here I use are for quadratic systems because they're a little bit more difficult than linear quadratic systems. So remember that the steps are the same for linear quadratic, just actually a little bit easier. So it says, solve the following system using substitution. And so you should remember substitution from grade 10. And what you need to do is isolate a variable. In our case, we're always going to choose to isolate y in either equation and then substitute it into the other equation. So looking at these two, it looks like it's probably easier to get y in the first equation isolated. So I'm going to -7 and -7. So I have y is equal to x squared plus 4x minus 7. Now I have y isolated. I can take that equation and substitute it in for y in the other equation. So this becomes 2 times y, which is equivalent to the expression I'm going to substitute in. X squared plus 4x minus 7 equals, this stays the same. I haven't changed that. 4x squared minus 10x plus 10. Now solving for substitution, what I'm going to need to do is get everything to one side. Once I have everything to one side, I'm just going to solve it like we would have solved last unit, solving for, an x value by either factoring, completing the squares, or quadratic formula. So first thing I got to do is multiply this 2 into the brackets. So this is 2x squared. 2 times 4x is plus 8x. 2 times -7 is -14. Equals 4x squared minus 10x plus 10. Now, whatever side you want to move everything to, it doesn't matter. I'm going to choose to move these guys over here because otherwise I'd end up with a negative coefficient if I move this way. So I'm going to subtract 2x squared, subtract 2x squared. So that's going to give me 2x squared minus 8x minus 8x. So that's going to give me a negative 18x. And add 14, add 14. So this will give me a positive 24. Now what I want to do is I want to factor. I want to solve for x. So the first thing I'm going to do to factor here is just try and remove out a greatest common factor. There's actually a greatest common factor of 2 here, which leaves me with x squared minus 9x plus 12. Now I have a nice trinomial. My leading coefficient is equal to 1. So I'm just looking for 2 numbers that multiply to 12 and add to -9. So 2 numbers that multiply to 12 and add to -9. 2 numbers that multiply to 12 and add to -9. I don't have 2 numbers that satisfy those conditions, unfortunately. So then I need to take this information and put it into the quadratic formula. Now, whether you want to use this equation or this equation for the quadratic formula, it's not really going to change. So I'm going to go x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And so negative a, b, c, or you could do a, b, c, it doesn't matter. Once this is here, I don't really need it for this. It'll cancel out anyways. But so negative b, so a negative 9 plus or minus the square root of negative 9 squared minus 4ac, all divided by 2 times a, which is 1. So this becomes negative 9. Negative 9 is positive 9 plus or minus 81 minus 4 times 12. So plus or minus the square root of 33 over 2. So when I do this, I'm actually going to have 2 answers, really ugly answers. So 9 plus the square root of 33 divided by 2 gives me the first answer. If I add those, I get 7.37. If I go subtract them, I get, so x is equal to this, and x is equal to 1.63, let's round. Okay, so there's my 2 set of answers. Now, I'm not finished this question because I need to take that information and solve for the full point of intersection. All I've done up to this point is say what the x coordinate of the intersection is. So 7.37 and 1.6, I need to go find the full point. So with x is equal to 7.37, I'm rounding, and x is equal to 1.63. I round, so it might be a little bit far away that when I try and verify it, but it should still work. Now, I need to substitute into one of these equations to find the full point. I'm going to take that and substitute it into here because that already helps me solve for y. So y is equal to 7.37 squared plus 4 times 7.37 minus 7. So 7.37 squared plus 4 times 7.37 minus 7. So y is equal to 76 let's round to 80. So there's a coordinate, really ugly, at 7.37, comma 76.8. That's my first one. I'll do the same thing with the other x coordinate, where I'll substitute this into here. So now I would just do the same thing with 1.63. So 1.63 squared plus 4 times 1.63 minus 7 from that, y is equal to 2.18. So the other point is at 1.63 and 2.18. All right. And I would get the same equation if I chose to use the unfactored form to solve for the x's as well. So that's substitution. Isolate y in one equation, substitute it into the other. Now you should have only one variable left, and you'll have to factor, complete the square, or use quadratics to solve for x. Once you know x, substitute that into the either equation to solve for y. Now that I have my solutions here, I could technically just go graph both of these, and I should be able to find the exact solutions that are there. Okay. So next one is elimination. Again, we should kind of remember what elimination is from grade 10. So when we are eliminating, we are going to add or subtract equations to try to eliminate a variable. When we do that, what we want to make sure is, first of all, like terms are on top of each other. Here, like terms are not on top of each other. So the first thing I'm going to do is rearrange this so everything's kind of lined up. I actually don't need to change this equation. Everything's on one side, so I'll leave it as x squared minus y plus 7x minus 5 is equal to 0. And I'd bring this over. So 0 is equal to 6x squared minus 2y plus 8x plus 10. So now everything is in like rows, and if I tried to add or subtract right now, I wouldn't eliminate. When we're doing elimination, especially when you have a quadratic, or either for this case, we always want to eliminate y. I want to get rid of y. So in order to eliminate, I need to make sure the coefficients are the same. So I need to get this one here to be 2. So I would take this entire equation and times it by 2. So this would become, I'll work down here, 0 is equal to 2x squared minus 2y plus 14x minus 10. And I haven't changed this equation because the y was already what I wanted it to be. So 0 equals 6x squared minus 2y plus 8x plus 10. Now what I need to do is go solve. So I need to eliminate. Now if I eliminate by adding here, -2 plus -2 is going to give me a -4. It doesn't eliminate. So I need to say, I'm going to take these equations and I'm going to subtract them. So 2 minus 6 is going to give me a -4x squared. -2 minus a -2, so -2 plus 2 is like 0y, so that's gone. 14 minus 8. 14 minus 8 is going to give me plus 6x. And -10 minus 10 is going to give me a -20. Excuse me. So this is going to equal -4x squared plus 6x minus 20. And now I'm looking to factor that, or I'm looking to solve for x. I could complete the squares. I could factor. I could use a quadratic formula. Doesn't really matter. If I look at this, I know I don't want to complete the square because I'd have to take out a 4. I'd be left with the 3, then I'd have to go 3/2, and I'd start dealing with fractions. I don't want to do that. If I tried to divide this even by 2, I'm not going to get a trinomial that I can factor nicely. So I have to use the quadratic formula to try and figure out my values of x. So negative b plus or minus the square root of b squared minus 4ac divided by 2 times -4. So this becomes -6 plus or minus the square root of 36 minus -4 times -20 is going to give me a -44 over -8. And you should see this and remember from last unit, as soon as I have a negative underneath that square root in the quadratic formula, that's called my discriminant, it tells me that there is going to be no solutions. So what does that mean in the context of this question? Well, that means these two lines don't intersect. Okay, so no intersection for these two. I just want to also point out, if you got to the place here, where you're here, and you either add or subtract and everything cancels out, that means those expressions are equivalent. They're completely the same, and so you would have an infinite amount of solutions. Okay. The last type of question or questions that we deal with here are those real world life questions. And so these questions overlap with a lot of the questions from last unit. So let's go take a look. It says a soccer and a football are kicked from the ground right next to each other. The soccer ball reaches a maximum height of 8 meters and travels 44 meters before landing. A football reaches a maximum height of 14 meters and travels 32 meters before landing. Determine the equation of the parabola that describes the height as the function of the horizontal distance for the football and the soccer ball, and use the equation to find the position where the balls are the same height and horizontal position. So let's go kind of divide up information. So I have this soccer ball. So we know like kind of what's happening here is I have this soccer ball. It's going to start right here because they're both starting at the same position, which will make 0, 0 to have our lives easy. It's going to reach a maximum height of 8 meters. So this is going to come up to 8. And it travels all the way to 44 meters. And I should be able to take information from that and make an equation. So I know going into y equals ax minus p squared plus q, this point right here would be at 12, comma 8. Because the vertex is going to be halfway between these points. Or sorry, that should be 22.
Excuse interruption. Ray is going to be back from his principal meeting at district office and would like the staff to join for a meeting at 2:45. I think we'll meet in the library.
Okay, so I can figure out that vertex point. So this is y is a x minus p, which is this, so minus 22 squared plus 8. Now I can go solve for the a value by substituting either this point or this point into there. Well, I'm going to choose 0, 0 because that'll make my life easier. So to solve for a, I'd subtract 8. So negative 8 is equal to a times whatever 22 squared is, 484. So I divide that by 484 and 484. So negative 8 divided by 484 in lowest terms. I would have an equation. So a is equal to negative 2 over 121. So my soccer ball equation is y is equal to negative 2 over 121 times by x minus 22 squared plus 8. Second equation is dealing with the football. So the football reaches a maximum height of 14 meters and travels 32 before it lands. So I take this football, it's going to go higher, but it lands quicker. And so here, this is 32. It reaches a maximum height of 14. The middle vertex, that axis of symmetry, is just going to be half of 32. So there's a vertex right here at 16, 14. And I'll determine the equation the same way I just did the soccer ball. So y is equal to a x minus 16 squared plus 14. And I have to go solve for the value of a. I know 2 points as well. I know this point and this point, but 0, 0 makes my life easy. So I'll put 0, a 0 minus 16 squared plus 14. So I'll solve for a by subtracting 14 from either side. And then I have 16 squared, or negative 16 squared, which is 256a. So divide by 256. So negative 14 divided by 256. So a is equal to negative 7 over 128. So that's my football equation. Y is equal to negative 7 over 128. X minus 16 squared plus 14. So some pretty ugly equations, really, but we should have all the prerequisite skills to create those equations. Now, what they're asking me is like, well, where are they kind of at the same place? Where did they cross in their trajectories? And so let's go take a look. I'm going to just graph both of these because that's the easiest thing to do. So I'll go to my graphing calculator. I got to remember that equation. Negative 2 over 121